Our warm-up for this video is page 2 on the practice test number 18. So explain the error, use complete sentences, and then solve the equation correctly. So look through the problem, see if you can find where the error is. Usually they have you circle whichever step is incorrect, and if you see more than one step incorrect, circle as many as you see an error in, and then off to the side, and I just labeled these line 1, line 2, line 3, line 4, line 5. I found that in the error it's easier to say in line 3 the student did blank when they should have done blank. And try to use your mathematical language when you do it. Talk about distribution, talk about combining like terms, simplifying a fraction incorrectly, whatever it is, but try to use mathematical terms when you describe the error. So look through the whole thing, circle any lines that have errors, and then in complete sentences or sentence, write what the student did incorrect. Then off to the side, solve it correctly, and write your new answer. Okay, so go ahead and stop your video, work the problem, and then we will come back and see how you did. Okay, so line 1 is the original problem, so obviously we're not going to label that. After I labeled them, I thought, oh, I should have called this line 1, but oh well. So obviously there can't be a label or an error in the first line since it is the original problem. So going from the first line to the second line, -2 times x is -2x. -2 times -5. Uh-oh. That should be positive 10. Remember how I told you that's a big, huge error by students? So when we make these problems, we always do student errors that we see common. And this is a great way to learn too, by looking for errors. I can tell you that for 10 years I was a tutor along with a teacher. So I was raising my kids, so I taught 2 or 3 classes a day, and then I went into the tutoring lab and helped my students during office hours. And that is where I learned more math than anything. Students would come in, I don't know where my error is. Can you show me where my error is? And finding errors in other students' work, priceless. Okay, so let's continue on and make sure no other mistakes were made. So we know this line is definitely an error. And so then they would have had -2x plus 8x is 6x, and they had -10, so that would have been correct with their work. So 8x minus 2x is 6x minus 10. That looks good. Add 10 to both sides. Yep, that step looks good too. 6x equals 15. Divide 6 by both sides, or divide 6 into both sides, I should say. So that leaves us with x equals 15/6, and then each of those is divisible by 3. So divide by 3, divide by 3. 15 divided by 3 is 5, 6 divided by 3 is 2. So it looks like only line 2 has an error. So let's go ahead and write down that error, and then we'll go back to working it. So the error in the work above. In line 2, the student distributed -2 times -5, and remember this is called distributive property. The student distributed -2 times -5 and wrote -10. It should be positive 10. And you could probably write that better than I did there. I just kind of did it off the cuff there. But I used my vocabulary. I described the error. In line 2, the student distributed -2 times -5 and wrote -10. It should be +10. So you should have something to that effect. Or you could say when the student was multiplying -2 times -5 during distribution, they wrote the wrong sign or something to that effect. Okay, so let's start here on the step where the error was made. So this should be 5 equals -2x plus 10 plus 8x. Oh, they didn't give us much room here, did they? So -2x, instead of -10, it should be plus 10 plus 8x. Line 3 will now be 5 equals, it's still going to be 6x. 8x minus 2x is 6x, but now it's going to be plus 10. So at this point, I like to flip it over. 6x plus 10 equals 5. Subtract 10, subtract 10. 6x equals -5. Divide by 6, divide by 6, so I get -5/6. So 6x plus 10, flip the equation over, and I'm sorry that looks bad there. 6x plus 10 equals 5, subtract 10, subtract 10, 6x equals -5, divide by 6, divide by 6, so we get -5/6. And there you have it. So before our next video, I'll have you do another one in case you struggled a little bit on that. Get some extra practice in, and then after that, every video will have a word problem at the beginning. So we'll start practicing our word problems since your test is coming up. Okay, so we are ready. Still on lesson 5. We have 2 more pages left. So this is lesson 5 in that big packet that was listed under the second day of class. And we're on page 17. So we're going to work on percent and mixture problems. So we're doing the percents on this side, and then probably in the next video, depending on how long this one takes, then we'll switch to the mixture problems. So I put a couple reminders here back from your translation days. Remember, is translate to equal, and of translates to multiplication. And we had that highlighted under our multiplication when we were doing the operations, the keywords. Where was that? It wasn't too long ago, I remember. There we go, page 13. So that was one of the words we had highlighted for multiplication. Very common, actually, especially with percents. So these are going to be done just like you did your translations. We're going to word for word translate the words into a mathematical equation. And I know it's a mathematical equation because they both have the word is in them. And then we're going to solve. And this you definitely want to make sure you have a calculator for, because this can be a lot of busy work. On the next page, we're also going to do a percent increase or percent decrease formula. And I like to write it with letters because that's how I remember it. No over O. So anytime someone asks for a percent increase or decrease, that's immediately what my mind says. No over O. So new minus old over old. So whatever number you have there will be there. And that's how we can find how much a product went up in price or how much a product went down in price. But that's for the next page. I just put that there on the formulas. So let's go ahead and highlight that, since that's a pretty key formula in percents. There's a lot of times they ask us, wow, how much did that go up? What percent did that price go up? Or what percent did that price go down? And now all you have to remember is no over O. So new minus old over old. I don't know what made me think to memorize it that way, but to this day, I see the word percent increase or percent decrease, and boom, I immediately write the N minus O over O. So that's how I remember it. So direct translation, the number 22 is, like it says above, is equals what percent? So I'm just going to call it N of 40. And you know what? I'm going to put a little percent sign there to remind myself that N is a percent at the end. So instead of writing N equals 0.80, I'll say N equals 80%. So that's just kind of my reminder. Don't forget that this question wants a percent as the answer, not a decimal. Okay, then just like we've been doing for the past almost this entire module since we learned lesson 3, we've been solving equations. I always put it over on the left. And even if you wanted to write it as 40N instead of N times 40, could do that too. But I like the letter I'm solving for on the left because like I told you, I see students all the time go divide by 22, divide by 22. I'm like, what? Had they had it written the right way, they wouldn't have divided incorrectly. So to get N alone, we do the opposite of times 40, which is divide by 40. And so our N is alone. And this is when you really want a calculator, because doing 40 into 22 or 22 divided by 40, that could take you a while. I mean, that could make the difference between finishing a test and not finishing a test, having to do a long division problem like that. So just easier to, and use your division key, not fraction. I don't want a fraction answer. I have that question asked often by students. How do you know when to use the fraction bar and when to use division? Well, I use a fraction bar when I want a fraction answer. I use the division key when I want a decimal. I want a decimal so I can turn it into a percent. So that's why I use the division key here. But they can be used interchangeably, but it comes down to, because they both mean the same thing, a fraction bar means the same thing as division. What form do you want your answer? And to turn it into a percent, I want a decimal. And so that is 0.55. And then I have my little reminder there. Don't forget to write N as a percent. So to write a number as a percent, you move it 2 to the right. So that would be N equals 55%. So 22 is 55% of 40. Nice, right? And if you wanted to check it, you could do 55% of 40. 0.55 times 40. Does that give me 22? Ding, ding, ding. It sure does. Okay, since you saw one in action, I'll let you try one now. So go ahead and shut off your video. Write your translation as an equation. Maybe flip it if you need to. Solve the equation. This one just wants what number, so your final answer will not be written as a percent. Just whatever you get in your calculator, that's your answer. And then join back up when you're done, and we'll check and see how you did. For our translation, 150 means equals 40%. Now we don't want 40% because we need to type this into the calculator. So to change a decimal to a percent, we move right 2. So to change a percent to a decimal, we move left 2. So this would be 0.40, or you could just write 0.4, obviously. Because remember, when we take a percent sign off, and I taught you this in another section, per means divide, cent means 100. 100 cents in a dollar. Century, 100. So divide by 100. So take 40, divide by 100, and there it is, 0.4. Same thing we have there. And then of, we know, means times what number? So I am going to flip it around just so I don't do anything incorrectly because it's written the wrong way. So 0.40 times n equals 150. Then we're going to divide both sides by 0.40. Divide by 0.40. And remember, this one we don't have to do a percent, and that's why I always have to label it when I do, to remind me, oh, don't forget to write this one as a percent. So we have 150 divided by 0.40, and like I said, you can write 0.4 as well, 375. And then, like the directions said when we started the word problems, you should always make sure your answer makes sense. 150 is 40% of 375. So 40% is a little under half, and 150 is a little under half of 375. So that answer makes sense. So percent problem's easy. Some of you may have learned that is over of equals percent over 100. I like that too. This is just a translation chapter. That's why I did it as a translation, but you get the same answer. Is over of equals percent over 100. Okay, so this one's just a fun little easy one here. This next one. So when we have a circle graph, so imagine there's a circle graph out here. What I did is just write what each percent was. They have to sum to 100. And I just, before I did this problem for the first time, I just verified it. 4, 8, 12, 13, 14, 15, 16. 40 plus 16 is 56. 56 plus, what is this? 44. There you go. So I verified that they equaled 100, but they're telling us they do. And this is the breakdown of pets owned in the United States. Use this information to answer the following questions. What percents are cats or birds? So cats are 23, or birds are 4. So we can say that is 27%. So a little over a fourth of the graph is cats and birds, because a fourth is 25%, right? Cats or birds. What percent of the pets are not dogs? And I know that most of you probably have not taken the 1-4X class. It's called it's liberal arts math, but it's called, what is the official name of it? College Mathematics. And it's for the liberal arts majors. So if you're going to be a criminal justice major, or you're going to be a sociology major, so it's English major, history major, you would take the 1-4 class. And they teach you about this, not dogs. So anytime there's a not in it, you start with 100%. And subtract out what's there. Could you do it another way? Sure, you could get out your calculator and you could add all those, but that takes a lot longer. So anytime it says not, you know the whole graph is 100. So it's 100 minus 21. 100 minus 20 is 80, and one more would be 79%. So 79% is not dogs. But you would have gotten the same answer if you would have went this plus this plus this plus this plus this plus this as well. Okay, currently there are 377.41 million pets in the United States. How many of these would be reptile? And so this is how I say it in my head. 4% of the pets are reptiles. So you could even write it down just to help you visualize it. 4% of the pets are reptiles. And then I have a little a little sentence right there to translate. Because a lot of students wouldn't just pick up on what to do on this problem, but when I write it in words, they're like, oh, I get it. It's 4% times the number of pets. Ding, 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 ding. So remember when I told you one of the most helpful things in solving any kind of algebra problem, but in particular math or word problems, is put it in your words. Make it look like how you want it to look, not how the problem's given. Put it in your familiar format. So this is familiar to us because that's what we've been doing most of this chapter, is solving equations and translating. So 4% times the number of pets are reptiles. So when we take the percent sign off, we have to move over 2. So this would be 0.04 of means times the pets. How many pets are there? 377.41 equals, and is, are is the past tense of is, so are also means equals. Because, or maybe not past tense, it's the plural of is, right? He is, they are. Yes, it's the plural of is. And so that also means equals, and then you can just call this x. So x is the number of reptiles. And this is just a pure calculator problem. So we do 0.04 times 377.41. I look at my screen to make sure everything looks good. Looks good. And now here's something that you're going to learn is super, super important, especially when you're doing computerized tests. And they only have one answer in their memory bank. So you don't follow the directions, they are not going to count it right. So 1/10 of a million. 1/10 is 1 decimal place. And how I remember tenths, hundreds, thousands, or how I help my students remember is 10 has 1 0. So 1/10 is 1 decimal place. 100 has 2 zeros. So the hundredths place is 2 decimal places. So see the pattern? So it's 1/10. The number 10 has 1 0, so 1/10 means 1 decimal place. So I write my 15, and then to round to 1 decimal place, you underline that place value, and you say, does it stay 0, or does it become 1? 0 followed by a 9 says change it into 1. So we need our little approximate symbols, which I forgot, approximately 15.1. And you write that and you're going to get it wrong. Oh, excuse me. So it's approximately 15.1 million reptiles. So don't forget to put your proper labels on it. It's not 15.1 reptiles, it's 15.1 million reptiles. So that's another thing that would be really handy to circle so you don't forget. And so that would be the appropriate label for that answer. 15.1 million reptiles. There you have it. So let's do a couple word problems with percentages. So a surfboard was originally purchased for $400. Oh, it was originally purchased for $400, and it was sold on eBay at a discount of 40% of the original price. So your translation knowledge from the second day of class will never, ever go away. You are continually doing translations, even when you're um, not in the translation section, but especially during word problems. So that right there is the key to the problem. 40% of the original price. So we can find, and that's going to be the discount. 40% of the original price. So we would write discount equals 0.40 of means times original price 400. So that translation knowledge you learned is priceless. You will see yourself use that so many times in your math journey. So the discount, 40% of the original price. So I can tell that's going to be 160, but I'll verify it on the calculator. So, whoops, a little bit blurry there. There we go. 0.40 times 400 is 160. And it's important that you label it as the discount, like it says in the wording, because they ask you for two answers here, and you got to know which one's which. So the person who bought the surfboard saved $160 off the original price. So discount, 40% of 400. So then to find the new price, I think you guys all probably know that. You take the original minus the discount, and that gives us $240. 400 minus 160, 240. Nice, huh? So knowing translations, very helpful when you are doing word problems with percents. Okay, I'm going to let you guys try example 5 since it's similar to this one. The only difference is you're going to be adding to your meal cost with the tip instead of subtracting with the discount. Only difference. Okay. So go ahead and work that one out and then join back and we'll see how you did. Okay, so you have to understand when you're doing a tip is, in this case, 20% of the meal. Right? Because you can't just say 20%. It has to be 20% of something, and it's 20% of the meal cost, I guess I should say. So just like this was 40% of the original, this is 20% of the original. So then we turn that into a math equation. 0.20 of means times 40.50. So the tip is going to be 0.20 times 40.50. And that gives me, and does everybody know that I can't write that down? So I even have 126 students still missing this for this reason. You have to remember what you're finding. You're finding the tip. And is anybody ever going to say the tip's 8.1? No. Dollars and cents are 2 decimal places. So don't think your calculator has these innate abilities to make it into dollars and cents. Sometimes you have to stop a moment and make it into dollars and cents. So you need to add a 0 when you write that down. It will be counted wrong because we don't write money with 1 decimal place. We write money with, this is called dimes and pennies. So dollars, dimes, and pennies. So this is the nearest cent. Okay. And then it says, find the total cost if a 20% tip is added. So the total cost is going to be the meal plus the tip. So that will be $40.50 plus $8.10. And usually on these types of problems, Alex will have two parts. Part A, or part 1, find the tip. Part 2, find the total cost of the meal. So usually they do it in parts, so that will be one of your answers. So you do need to make sure and put that 0 in. So I had the 810 in my screen, so I'm just going to add it to 40.50. You can probably do that in your head. What? 48.60? Yep, there it is. $48.60. And that would be labeled as the total. Or total cost maybe would even be better. So the meal plus the tip gives us the total cost. Okay, I think we're going to stop there, and we have one more page left in our next video. So I'll see you then.